Laurentian lecture series. My name is Kim Hissong, and I'm the Executive Director of Annual Giving and Laurentian Engagement here at St. Lawrence. And we're very excited to be offering this new lecture series as a way for alumni, parents, and friends to experience today's classrooms firsthand, albeit virtually. Before we get started, I'd like to cover just a few technical items that should help make your webinar experience a more enjoyable one. At various points throughout the lecture, we will pause to invite comments and questions, and there are two ways that you can do that. You can virtually raise your hand using the hand icon in the navigation pane that you should see at the top right of your screen. The icon is a small hand that will appear in either blue or yellow towards the bottom of that side bar. You can click it once to raise your hand, and when you're called on, you will be unmuted and you can ask your question directly. The second option is to simply type your question or comment in if you prefer. If we're unable to get to all of the questions tonight, we will provide contact information for Dr. Estevez, and you are invited to be in touch with her directly. Just a few tips about the webinar audio. If you are using the audio through your computer, please know that you must have a built-in microphone or an external microphone in order to ask questions. Otherwise, you'll be able to hear us, but unfortunately, we won't be able to hear you. If you're using the audio through your telephone, if you have your phone on speaker during the webinar, in order for us to hear your question, you will likely need to take the speaker off during that time and use your handset. We recommend that during the webinar you minimize the navigation pane by using the orange arrow near the top to minimize the pane. And if you need to maximize the pane at any point in time to ask a question or to make a comment, simply use the orange arrow to maximize it. So without further delay, I am pleased to introduce our lecturer for the evening, Dr. Ana Estevez, Associate Professor of Biology and Psychology here at St. Lawrence. Tonight's lecture is entitled Neurocognitive Enhancement. So welcome to Ana.
Thank you. Good evening, and thank you all of you for joining me tonight on a topic that I think is very relevant for our society today. I know that there are a lot of former students in the audience, but the majority of you don't know who I am. So I thought I'd start a little bit by giving you a little bit of background on myself. I grew up in Brooklyn, New York, and I did my undergraduate degree at Binghamton University, and I earned a BS in psychobiology, which is essentially neuroscience. They just didn't call it that. And from Binghamton, I went and pursued my PhD in neurophysiology at the Wayne State University in Detroit. And from Detroit, I moved on to Vanderbilt, down south, to pursue a postdoctoral fellowship looking at cellular mechanisms in neurons. And so I did that for a couple of years, and I was then promoted to research professor until I then moved here to St. Lawrence. So I came here in 2005 to help with a new major that was being established at the time, the neuroscience major. So my position is a joint position between biology and psychology. And my research interests are in neurodegeneration and neuroprotection, so how to protect brain cells from dying after a stress like a stroke. In my research, I use the small nematode C. elegans, it's a small roundworm, or cultured cells as my model system. So I'm essentially a cellular neuroscientist. That's my background. And so I contribute here to the different courses relevant to the neuroscience major, Introduction to Neuroscience, Intro to Cell Biology, Advanced Neuroscience, and then some upper-level electives for the majors, which some of my students have taken, cellular mechanisms of memory, current topics in neuroscience, and drugs in the brain, which is the topic where I got the idea to do this topic for the webinar today. This is something that we discussed in that class. So there's a picture of me. I'm not being narcissistic. I just figured a lot of you don't know who I am, so it would be nice to sort of have an idea of who's the voice on the other line. So before we get started, I wanted to cover a few definitions so that everybody's on the same page related to the topic that I'm going to cover. And one of the big questions is what exactly makes a psychoactive drug? So whenever we mention the word psychoactive drug, we're referring to any chemical substance that can alter mood, thought processes, or behaviors. And so a lot of these drugs can actually be used to manage illness, but they're also used or abused recreationally. One of the things that I'd like to remind everybody is that when we talk about a drug that has these effects on the brain to change mood and thought processes, that these drugs don't do something new. They basically act on the existing pathways that are in the brain. So they don't induce something novel. They basically act on the existing signaling systems that are in our brains already to be able to induce their effects. And most of these drugs act on what we call our existing neurotransmitter systems. So these are the chemical signaling molecules that brain cells use to communicate with one another. And so what we'll see today with some of the drugs that we're going to talk about is that they alter how these neurotransmitters or chemical messengers have their effects. So again, just to emphasize that any psychoactive drug has its effect because it already acts on existing signaling pathways. Okay, so we're going to talk today about neurocognitive enhancement, and so I wanted to define what that was so that everybody is on the same page with the definition. And the idea is that it's the use of a psychoactive drug, so something that changes your mood, thought processes, or behavior, by individuals that were not necessarily prescribed these compounds. So I call these healthy individuals, meaning that they were not necessarily prescribed these medicines by their physicians. And a lot of people use these in order to enhance memory, to induce arousal or be more alert, or to improve their executive function. And what we mean by executive function are some of these abilities of the brain that helps you be able to plan, helps you to be able to make decisions, be able to control your behavior. Those are things that we mean by executive function. And this is just a cover of the Scientific American a few years back, pretty much covering this topic, the idea, can you use pills to make you smart? So that's where the idea of neurocognitive enhancement comes up. So these drugs were not developed for the purpose of making people smart. They were actually originally developed for the treatment of various disorders. So, for example, Alzheimer's disease is characterized by cognitive decline during the course of the disorder. So a lot of these medicines were developed to help slow down that cognitive decline that you see in Alzheimer's disease. Attention deficit hyperactivity disorder, which is relevant to what we're going to talk today, some of these drugs were designed to help individuals that have been diagnosed with that disorder. And these neurocognitive enhancing drugs are not all the same. They all affect various neurotransmitters. So if you remember, again, neurotransmitters are these chemical messengers that our brain cells use to communicate with one another. One example is dopamine. So dopamine is one of the neurotransmitters that's affected by drugs like amphetamines. So Adderall or Dexedrine or methylphenidate all have the effects that they have on the brain because of the effects that they have on the dopamine neurotransmitter. There's drugs that are called ampakines. Those affect a completely different transmitter and they have different effects. But again, the common thing that they all have is that they are drugs that are used for neurocognitive enhancement. And again, acetylcholine, cholinergic drugs, and one example there is Aricept. Again, that particular drug works specifically on acetylcholine as the neurotransmitter, and that's one of an example of the drugs that's used to treat Alzheimer's disease. So that somebody is diagnosed early on with possible Alzheimer's disease, that the doctors might give them Aricept to slow down their cognitive decline. So what we're going to do today is we're not going to talk about all these drugs as neurocognitive enhancers. I'm going to talk about just one example. And so we'll use the example of drugs that affect dopamine, so amphetamines and methylphenidate. And we'll have to talk a little bit about how these drugs are first used to treat attention deficit hyperactivity disorder. So this is sort of the overview of what we're going to do for the rest of the lecture. And again, there's going to be times where I'll pause to ask if anybody has any questions. So what we'll do first is talk a little bit about the mechanism of action of amphetamines and basically, hopefully, help you understand why amphetamines are effective for treating attention deficit hyperactivity disorder. Then we'll look at a little bit of the demographics of who's using these drugs for not ADHD treatment, but instead for neurocognitive enhancement. And then finally, the last portion of the lecture is going to revolve around what are the issues that we have to think about with individuals using these drugs to be able to increase their cognitive abilities in terms of, are they actually effective at doing that? Are there safety issues that we need to consider? And then finally, the ethics involved in having healthy individuals taking medicines that they were not prescribed. Okay, so we'll start first by looking at the mechanism of action of drugs that are like amphetamine. So amphetamines like Adderall or methylphenidate, also known as Ritalin, the way that they have their effect is that they increase the levels of the neurotransmitter dopamine as well as the neurotransmitter norepinephrine at the synapse. So again, both of these are chemical molecules that are important for neurons to signal to one another. And this is an example here in this drawing of a dopaminergic synapse. So we're not going to go through both synapses, but the dopamine synapse can serve as an example for both. So if you look at this drawing here, what you will see is that it's called a presynaptic terminal. So this is the end of one neuron, one nerve cell, and it's going to communicate to the next cell nearby by releasing chemicals. In this case, dopamine is the main chemical that gets released. So you can't see the other cell, but the whole point is that the little blue dots represent dopamine, and when there's an electrical signal that arrives at the end of the terminal, that then the cell releases this chemical signal called dopamine so that it can have effect on cells nearby. So dopamine would be the chemical transmitter here. When you have a chemical signal, you don't want the dopamine to remain at the synapse for a long time, because then it fails to report what it was there to report, that there was an electrical change. So one of the things that cells have on this presynaptic terminal is a little transporter called the dopamine transporter. And so the dopamine transporter that's labeled DAT in this picture is basically important for taking up that excess dopamine that was released and putting it back into the cell. You don't want to leave it there for too long, because then you're not communicating the signal properly. So DAT is a molecule that exists to help return the dopamine that gets released back to that cell so that it can be recycled and used for the next electrical impulse that comes into the cell. That's that there that I highlighted with the red circle. So what amphetamines do is that they cause the reversal of this transporter. In other words, instead of this transporter taking dopamine and putting it back into the cell, amphetamines have the effect of making the cell actually put more dopamine out at the synapse. So in essence, what these molecules do is that they increase the level of neurotransmitters that is available at the synapse, thereby activating the cells that are nearby a lot more. So this is the same thing that happens in a norepinephrine synapse. It's very analogous. So in another synapse that has norepinephrine, you would see norepinephrine in the terminal, in the little vesicles, and when it gets released, it gets taken up by its transporter, which is called the norepinephrine transporter. It's very analogous. But amphetamine has the effect that it basically causes both of these transporters to reverse. So instead of storing dopamine, you're releasing more dopamine and more norepinephrine into the synapse. So these types of medicines have that effect, that they increase the levels of both of those types of neurotransmitters at the synapse. So in essence, what they end up functioning as, when you do this in the brain, they end up functioning as what we call psychomotor stimulants. And basically, they have the effect of increasing alertness, heightening arousal, and causing behavioral excitement. So again, these effects are caused because of your increasing dopamine and norepinephrine, both of these chemical transmitters, at their respective synapses in different parts of the brain. So here we're going to see the example of different dopaminergic pathways of the brain. There are 4 main pathways that release dopamine in the brain. And basically, the amphetamines are going to cause release of dopamine by all of them. The 2 main ones that we're going to be concerned about for this talk are the mesolimbic pathway and the mesocortical pathway. Both of these pathways originate in this little area of the brain where you see the arrow pointing to the blue dot. It's called the ventral tegmental area. So they start there, and then they project, the neurons project their terminals all the way to different parts of the brain. So one of them is the mesolimbic tract. So this is the neurons that start at the ventral tegmental area, and they project to some limbic sites. And the role that it has there is to increase pleasure. So when you have something pleasurable, you increase dopamine at the mesolimbic sites. And also memory, so modulating memory at the level of the hippocampus, which is a very important part of your brain for memory. So increasing dopamine at the mesolimbic pathway has the result of increasing pleasure and also increasing memory. If you increase dopamine at the mesocortical site, which is the longer tract that projects all the way up to the front of the brain, the effect that dopamine has there is to increase attention, increase what we call executive function, all these abilities for planning, impulse control, and behavioral modulation. So all those things are modulated by the mesocortical pathway. So in essence then, when you change dopamine signaling in the brain with amphetamines, you're affecting all of these pathways. And in particular, the two pathways that are very relevant for our discussion today are the mesolimbic pathway, which is involved with pleasure and memory, and then the mesocortical pathway, which is involved in attention and executive function. Okay, so let's transition to talking about why these medicines that increase dopamine at these different parts of the brain might be helpful for treating attention deficit and hyperactivity disorder. So this particular disorder, it's typically diagnosed in children, and it's in children that exhibit extreme degrees of inattentiveness, so difficulty in focusing, for example, impulsivity, and hyperkinesis. So a lot of times when we think about hyperkinesis, you think about somebody who's fidgety, who can't sit still for a long period of time. And so the Diagnostic and Statistical Manual of Mental Disorders, or the DSM-IV manual in this case, gives the criteria by which physicians diagnose ADHD. And so the idea, these are not, what I have here is not completely inclusive, it's just general categories, but they have to demonstrate 6 or more of a certain set of symptoms over 6 months that are disruptive and are inappropriate for the developmental level. So typically what happens is the parents get notices from the teachers at school that the child is having problems paying attention or following rules to stay still or focusing on a task for a period of time, and typically that's where parents start seeking help and figuring out what's going on. So the categories of symptoms, again, are 3 main categories. So hyperactivity, inattention, so typically you see that as the inability to focus. If you have to sit still and work on a project, this child has a difficulty doing that. Impulsivity, for example, blurting out answers, interrupting others. So there's a whole list of symptoms that are all listed out in the DSM-IV in terms of what the criteria are for diagnosis of ADHD. So what's interesting is that amphetamines, which are psychomotor stimulants, right? So you think about something that's a stimulant, and now you have a disorder in which the child displays hyperkinesis and is moving a lot, that actually amphetamines are used to treat ADHD, and they tend to be effective in greater than 50% of ADHD children. But the key is that it's low doses. So low doses of amphetamines produce a therapeutic effect in these children. And the question is, you know, we talked about a little bit about the different dopaminergic pathways that are involved with amphetamine. So which pathway might mediate this therapeutic effect? So we know that some of the symptoms, again, include inattention and impulsivity, that right away, one of the things that you think about is this mesocortical pathway. So that's the pathway that's involved in dopamine's ability to modulate attention, for example, and behavioral control. So that's where the therapeutic aspects of these medicines work for children that have been diagnosed with ADHD. It's still a little bit of a conundrum. It was for a while for scientists why something that's a stimulant actually works in a way to calm these individuals. And we'll get to that in a second, but again, just as a reminder that it's the prefrontal cortex, or this area at the front of the brain, that modulates executive functions. So things, again, like planning or inhibiting inappropriate responses, or being able to pay attention or have selective attention for a sustained period of time, that's all modulated by this area of the brain called the prefrontal cortex, and that the mesocortical pathway that releases dopamine helps to regulate that. So that's why it seems that changing dopamine levels in this part of the brain helps to improve those functions in individuals with ADHD. So again, it was a bit of a paradox for a lot of people to say, why is it that a stimulant can actually help calm some individuals who have been diagnosed with ADHD? And so in order to understand it a little bit better, I have a chart to help explain a little bit about the way scientists are thinking about this. And so what you see here is the y-axis is showing you what typical prefrontal cortex abilities are. So that part of the brain that is important for executive function in the front, right behind your eyes. So if you have very little prefrontal cortex ability, that means that you're distracted, you're disorganized, you're forgetful, you might be impulsive. If you have very high functioning prefrontal cortex ability, it means you're focused and organized and responsible. The idea is that you can modulate how that prefrontal cortex is functioning by having different levels of dopamine and norepinephrine in the prefrontal cortex. And so the dopamine and the norepinephrine can sort of modulate it. But the interesting thing is that it's not a linear effect. It seems to be a U-shaped curve. And so what do we mean by that? So if you look on the x-axis, you see that as you increase the levels of catecholamines, like dopamine and norepinephrine, that you can start from very low levels, means you're fatigued. Intermediate levels means you're just right, you're alert. But if it's too high, you become stressed. And so you have to really carefully modulate those levels to achieve the right amount of alertness as well as the right levels of prefrontal cortex. All right, so that's a lot to think about. So let's try and slow it and give you an example. So let's say somebody has very low levels of dopamine and norepinephrine. So they would fall where that red dot is on your screen. And if you follow that to the y-axis, you would say, okay, those low levels of dopamine and norepinephrine, the person is fatigued, and it also shows that they're very distracted, disorganized, and forgetful because their prefrontal cortex abilities are low at that particular level of those different neurotransmitters. On the other hand, if you have just the right amount of those neurotransmitters, just the right amount of dopamine and norepinephrine, the person is alert, so you can see that they fall under the category that's alert. And then if you trace that back to the y-axis, you see that now at that level of dopamine and norepinephrine, the person becomes focused and organized and responsible. So you want just the right amount of those different neurotransmitters. Now, if you go too high, which is my next example, so now let's say you have levels of dopamine and norepinephrine that are really, really high. Now the person feels stressed, and if you trace that down all the way to the y-axis, you see that now the prefrontal cortex abilities are back down to distracted, disorganized, forgetful, and impulsive. So the key is to have the right levels of these neurotransmitters in this part of the brain so that the prefrontal cortex functions at the optimal level. That if you have too little of these neurotransmitters, it's not going to function properly. The person is disorganized, distracted. And if you have too much, it's also bad. That you want the it's almost like Goldilocks, too little, too cold, too hot, and just right. So you want the just right amount, which would be the middle where you see the alert, so that you can see the optimal functioning of the prefrontal cortex. So if you have a good understanding of this U-shaped, inverted U-shaped prefrontal cortex function, then we can see where perhaps these medicines might be helpful for somebody who has ADHD. So the idea is that, again, low doses of stimulants like amphetamines are therapeutic in ADHD patients. So the idea is that in these individuals that the levels of dopamine and norepinephrine are too low. And so as you see on that red dot on the screen, that the levels are too low to begin with, and so their prefrontal cortex abilities are in that lower end where you see distraction and impulsiveness. And so when you give somebody low doses of amphetamine, somebody who has ADHD, that the idea is that you would then help them get to the levels that are up to the alert level, to the moderate levels, and that would in turn increase their ability to become focused and organized and responsible. So in individuals that have been diagnosed with ADHD, that you would help move their dopamine and norepinephrine levels from that low prefrontal cortex functioning ability all the way up so that they can focus better and be more organized. And so that's why low doses of these medicines help. But if you exceed these doses, then again, you're going to go back down that U shape and get to the stress levels and get back down in prefrontal cortex. So again, the key take-home message is that you want to get just that right amount of dopamine and norepinephrine at these synapses. And the way to do it is with low doses of these amphetamines. Okay, so I hope that you were able to understand a little bit of why these medicines are useful for treating ADHD. And now I'd like to move on to talk a little bit about neurocognitive enhancement, because the idea is that people have seen that these medicines actually work to improve cognitive function in folks that have been diagnosed with ADHD, and now there's a rise in the use of these medications for non-medical purposes. So these are individuals who have not been diagnosed with ADHD that are seeking to use these medicines for what we call cognitive enhancement, so that to improve upon their daily function. And again, the more commonly used ones are amphetamine-like drugs like Ritalin and Adderall. So I'd like to pause right now before we talk about the demographics of who's using neurocognitive enhancers to see if anybody has any questions regarding how these medicines work for ADHD. Did you need any clarification on how the prefrontal cortex function works? Any clarification or any question for me to repeat anything that you might have missed initially before we move on?
Okay, and just as a reminder, if you weren't on when we started the lecture, there are two ways that you can ask a question or make a comment. You can use the hand icon in the navigation pane. Raise your hand, we'll unmute you and call on you. Or if you prefer, you can also type in a question or comment and we'll get to those as well. So we're just going to take a moment to look to see if anyone has raised their hand. And I do see that it appears that Andre Weeks has raised his hand. Andre, would you like to go ahead and ask a question or make a comment?
Hi, Anna.
Andre, go ahead.
Hi, Andre. How are you?
Good. How are you?
Good, thanks. It's nice to hear from you. What's your question?
I'm just curious, when you talked about the upside down U shape, why does it do the U shape? Why doesn't it not go like more of like an increasing like linear pathway kind of, I guess, like to where you become more and more alert instead of going to stress?
Okay. Good question. So the idea, what Andre asked is, why does it go down? Why is it a U-shaped and why isn't it linear? The answer to that is that these neurotransmitters have effects on other pathways in the brain as well, not just the prefrontal cortex. So when you have excess norepinephrine, it's almost like having a fear response. It's too much adrenaline, and a lot of us have felt that under stressful situations. So the answer, the quick answer to Andre's question is, think about not just having these effects on the prefrontal cortex, but that you're having these other effects peripherally on the body that can then influence your ability to focus on anything if you have these high levels of stress hormones going through your system. So that's why it's a U-shaped curve.
We have a typed-in question from Olivia Herlock, and Olivia says, this isn't about the meds, but what are the natural ways that dopamine is released to the pathways?
Yes, very good question, Olivia. So one of the key roles of this neurotransmitter, and specifically in the pathways that it's involved, really is for our survival. So one of the things that dopamine is important for is for allowing us to feel pleasure and being able to remember that, so that we are able to then continue to pursue those things for survival. So what do I mean? When natural rewards is what we call them, like food, for example, should increase dopamine in the mesolimbic pathway. Sex as well, because you need it for reproduction. So those are all things that are called natural rewards, and dopamine plays a very important role in that, and they get released naturally without any drugs. So that's part of normal function. The other thing is that dopamine seems to play a role in reward prediction. So if you think you're going to get something good and you don't get it, so you release a little bit of dopamine to tell you that that was not what you expected. Or if you weren't expecting something good and something good came along, you also release dopamine. So it's a way to kind of make you alert to things that might stand out. That's a way to think about it.
We have another typed question from Carol Drew Riley, who says, can you comment on why some children with ADHD have a paradoxical effect for some ADHD prescriptions?
Can you clarify what you mean by paradoxical effect? I mean, if you mean perhaps why some work for some and not others, I think that's part of most medicines, that a lot of people have different genetic makeups, different environmental experiences, and because of that, you react differently to medicines. And so that's why, for example, with antidepressants, a lot of times people have to try multiple types of antidepressants before they find the one that works for them. And for ADHD meds, it could be something similar. So you might have to try multiple types. And also with each type, again, start at a really low dose until you reach just the right dose for each individual.
We have another question from Skip Hansen, who says, are there any medical investigations into doing a better job of regulating chemicals to always be in that right part of the U-shaped curve?
Oh, Skip, that's a good question, and that's hard because it's slightly different for everybody. And so that's a really, really tough question to just get the right amount. And again, when somebody is on medications, this is exactly why they have to start low and then slowly increase just to find the right dose for each person. Perhaps with the advent of what we call genomic medicine, where everybody's genome is going to get sequenced, that we might then know who are the ones that need a little bit more, and who needs the higher doses and who needs the lower doses. But we're still a little bit away from that.
Okay, it looks like we've answered everyone's question at this point, so we'll go back to the presentation and we'll come back to questions again in a little bit.
Okay, great questions, everybody. Okay, so what I wanted to do now is transition a little bit into who is using these medicines for cognitive enhancement purposes and why. Okay, so one of the things that prompted me into this topic is that I teach drugs in the brain as one of my classes, and this is something that we end up covering. And in looking for literature for some of my lectures, I ran across this survey that actually had been done in 2008 of people who read Nature. And Nature, for some of you who don't know, is one of the top life science journals. So that, you know, if I wanted to be you know, the big person in my field, Nature or Science is where I'm going to publish. So those are the really, really high-profile journals. And so they actually did a reader survey. So people who read Nature, they did an online poll, and they asked about this, the use of these drugs for enhancement purposes. So it wasn't just Adderall and methylphenidate. There were other drugs that they also included in this, but I thought this would be interesting to see. So the majority of people have never used, right? So, and again, this is a survey from selective population because it's people who read Nature. But there were 1,400 people who answered the survey, and they were from 60 different countries. So it's also a little bit, it's also very general. So the majority of the people had never used any of these for cognitive enhancement purposes. And the green line you can see are the people that are prescribed these medicines for medical purposes. So you can see the distribution there by age. But then if you look at the red line, those are the people that are using these types of medicines for enhancement purposes. And so I guess the two key points to see is that in terms of the percentages, the majority of the people who use this for cognitive enhancement purposes are less than 25 years old. And then there's a little bit of a spike in the 55 to 65-year-old age range. And I think that has to do a little bit with career advancement in terms of those individuals. And we'll go back to a little bit of some of the actual answers for some of the people. But one of the things that struck me was that a lot of college age and younger kids were actually taking these medicines for enhancement purposes. So I looked a little bit into some of the data regarding the non-medical use of these stimulants in college campuses, and I came across this interesting article from 2003. And what they did here is McCabe et al. Is they did a survey, so it was a survey form, so it was students answered the questions, of 119 different four-year colleges around the U.S. So they really tried to encompass schools all over the country. And they, based on the surveys that came in, they analyzed a representative sample of over close to 11,000 answers, right? So that they have a pretty decent sample size. And so this is representative of college students in 2001. And one of the key things that they found, and this is a busy table, and I'll highlight some of the relevant markers for you, is, again, they categorized them by admission criteria, so less competitive to most competitive. They also separated it based on geographical regions, and also based on commuter status, so whether it was a commuter school or it was a campus, much like St. Lawrence, where the students live on campus. The key numbers that I would like to highlight for you are, that the most competitive colleges tend to have the higher percentage of individuals. So one of the questions was, have you used this in the past year or in the past month? And typically the numbers for the most competitive colleges were higher in terms of students using these for enhancement purposes. And again, as a reminder, these are non-ADHD students. These are students that have not been prescribed this medicine. So the most competitive colleges stand out. The other thing that stands out for me, because this is where I work, is the Northeast. So the Northeast tends to have a higher prevalence of students that are taking these stimulants in a non-prescription-like setting. So most competitive colleges in the Northeast, I think, immediately think, oh my gosh, this is, St. Lawrence is represented in here for sure. Okay, so some of the key findings, again, were that the lifetime prevalence. So they asked, have you ever used these prescription medicines for non-medical purposes? In other words, you were not prescribed them, but you got them somehow. The lifetime prevalence was 6.9%. So about 7% of students have said that they've tried them at least once. And then if you asked about the past year, that number goes to about 4%. But the interesting thing is that depending on the campus, there's a bit of variability. And in some campuses, the past year prevalence was almost 20%. So that's a huge number for one campus to have about 20% of their students having used these medications, even though they were not prescribed this. The other key finding was this, that these non-medical prescription stimulant users were also more likely to report the use of alcohol, cigarettes, marijuana, ecstasy, cocaine, and other risky behaviors. Again, so the use of these sort of correlated with them using other types of drugs as well. The big question is, okay, so you're healthy, why do you want to take a medicine? And again, the key focus is for enhancement of these executive functions, right? So abilities that enable flexible, task-appropriate responses. And this is a cartoon that I got from the New York Times. It came out in 2008. And the implication is, okay, these guys are sort of having a really heated chess match, and this guy really, the other guy really wants to win, so he's going to take a little bit of a helper to help him sort of stay focused and do well. And again, this is in 2008, but it's very much relevant today. So again, things that people think might help them might be with attention, increasing your working memory, and also impulse control, again, which is where these medicines are very helpful for ADHD. In that survey in which I showed you earlier that reported, from individuals that read Nature, here are some of the answers. I mean, these were professors that were answering that survey, and here's two examples. So one is a U.S. professor and one is a British professor. And the drug that they're talking about here is modafinil, which is also a stimulant, but it works a little bit differently than Adderall and that methylphenidate, but still it's the same idea. So why do some people take it? So U.S. professor for jet lag. They actually got it prescribed by their primary care doctor, but they also realized that it does affect their cognition, and so that this individual likes the effects that it has on their attention and working memory and word finding. On the other hand, you see the British professor, obtained it on the internet. The magnitude effect is mild, but it's very valuable to her, increasing her mental energy and sustained hard thinking. So this is not just college students, but it's also been shown that professionals are actually using these medicines for these purposes, to sustain work harder, do more in less time. So what I want to talk about now is, okay, so we know that there's college students and also professionals that are using these medications. What are some of the issues that we should think about related to their use of these? And I sort of separated this into sort of 3 categories, where we talk about efficacy, safety, and ethical considerations. So we'll start with looking at the effectiveness. And the question here is, are these drugs actually effective in a healthy individual for those purposes? In other words, we've seen that for ADHD individuals, it does help. It does help them get their prefrontal cortex levels working so that they are less impulsive and less distracted. Is that the same? Can you get that effect in an individual that has not been diagnosed with ADHD? So we'll look at some examples of some studies that have looked at that. Okay, so here's a study that was done by Nora Volko's lab, and Nora is a very well-known neuroscientist that does a lot of brain imaging studies. And this was done in 2008, and what they did is that they imaged the brain of individuals while they were performing a cognitive task. And what they did was it was a repeated measure, so it was the same individual did the task before and after they were giving methylphenidate. And the individuals didn't know, so they were blind to treatment. They didn't know when they got it, so some individuals got the methylphenidate first, some got it second, so they controlled for a lot of those things. And when they put the data together, what they did is they mapped the statistics, and what they saw was that methylphenidate reduced the use of attentional resources on a cognitive task. In other words, the items that you see in yellow, all those things, those parts of the brain that you see that are labeled with yellow, are areas that had more activity when the person was on the placebo, right, when they didn't get the medicine, than when they were on methylphenidate. In other words, these areas were more active before the drug, and when the person took the drug, these areas became less active. So what that was an indicator of was focus, right? So when you're very focused, you don't have to activate all these different parts of the brain. So that's sort of an idea that suggests that, yeah, so methylphenidate does help with focus. The interesting thing was, when they looked at the data by individuals, what they saw was the following. What they saw was that the individuals who had that minimal activation under placebo, meaning that they didn't use much of, they used minimal resources under the placebo, were the ones that did not improve performance with methylphenidate. So what does that mean? So if you were already very well focused, that you didn't have to use all these attentional resources to begin with, then methylphenidate did nothing for you. On the other hand, if you actually, under placebo, actually ended up using a lot of different attentional resources, that when you would give a methylphenidate, it actually improved the performance. So the methylphenidate didn't improve everybody's performance. It improved primarily those that were underperforming. So again, just to repeat that, what this study showed was that those individuals who already have optimal focusing of brain resources showed no benefit from Ritalin. It was only the individuals who pretty much, if you could think about it, of having a scattered brain where you see all these different areas light up under placebo, then those individuals who were given methylphenidate, they actually did improve in focusing. But again, this is not something that was across the board beneficial for everybody. Here's another study, and here we're looking at a study that analyzed undergraduate GPA. So the idea is, okay, this is really a smart drug. If I take ADHD, do I perform better than everybody else? And the answer to that is no. So if you look at the mean GPAs, this is looking at the y-axis, and then the different groups are, the first group is the ADHD group who's taking the medicine for the ADHD. The second middle group, the white bars, are the individuals who don't have ADHD but are taking the medicines. And then the third group is individuals that don't have ADHD and they're not taking these medicines illicitly. And so what you can see is that the non-ADHD illicit use doesn't have a better GPA than the ones that are non-ADHD and don't use it illicitly, right? So if it made you smarter, then perhaps you would say, okay, if the person's taking these medicines, then perhaps their GPAs would be higher. One of the things that the study didn't look at, which is a question, is, well, what if we don't know how these individuals in the white bar would have performed without the drug, right? So what would have been their GPAs without the medicines? We don't know that. That's something that they have to study again and try to clarify that. But the overall idea is that they don't have higher GPAs than somebody who doesn't take these medicines. And then a more recent study that came out just recently in 2013, again, looking at these ideas, do these drugs lead to cognitive enhancement in healthy individuals? So all the individuals that are being studied here are people that have not been diagnosed with ADHD. And they did a whole battery of different types of cognitive tests to see how they performed with and without. In this case, it was Adderall. So they did a bunch of memory tests, recall tests, etc. And I'll show you just one of the results because it's very representative of their overall results. And so what they did, here's what you're looking at is word recall. And what you're looking at is they separated the groups into people that at baseline, in other words, when they were just on placebo, either performed below the median or above the median. So those are the two groups that you're looking at. They were basically put into those groups based on how they did on placebo. So what they showed is that the individuals that initially performed below the median actually showed an improvement when they were on Adderall, when it came to word recall. Okay, so these are individuals that were performing lower to begin with, and when you gave them the Adderall, they actually had a slight improvement. However, if you look at the individuals that were already performing high to begin with, so the above median baseline performers, the effect of Adderall was the opposite. It actually made them perform worse. So this is almost like the U-shaped curve that I showed you guys before. In terms of if you're below, you need a little bit of help to kind of get you up to optimal, but then beyond that, you actually risk performing worse, and that sort of supports that same idea. And this also supports, again, the idea from the study that Nora Volko described in the PET scan images, that again, when people were on the methylphenidate, those that performed better were the ones that were actually not doing well to begin with in the placebo. In other words, they had more brain activity in terms of scattered activity in the placebo, but then the methylphenidate helped them focus. But if they were already focused to begin with, the methylphenidate did not help. And so this is, again, sort of supporting that idea in a different way. And here we're just looking at a cognitive test. And those that were below the median to begin with actually improved on Adderall, but those that were above the median actually got worse. So in general, what they concluded from the study, based on all the different tests, this is not the only one that was on there, is that there was no enhancement of any cognitive abilities by Adderall for participants in general. And then this is another study, again, looking at the effectiveness of these medicines in healthy adults. And so here, again, they had healthy young adults, and they did a double blind. So the person who was giving them the medicine didn't know what they were getting, and then the individuals that were getting the medicine had no idea what they were getting. And they looked, again, at different assumptions on their cognitive function. And one of the key conclusions that they reached from the study was that a huge part of people's perception of them doing better, again, we're not talking about ADHD folks, we're talking about individuals that have not been diagnosed, that when they take these medicines, they actually experience what we call a substantial placebo effect that actually improves them, that improves their memory. So in other words, they improve their memory just because they thought they got methylphenidate, not because they actually got it. So you could have given them a sugar pill and told them, oh, that's methylphenidate, and they actually performed better, even though what they got was a sugar pill. So a big portion of the effect that we're looking at in terms of people saying, it works for me, a lot of it you have to consider that there's a substantial placebo effect involved. That is not necessarily the drug that's doing it, but it's the expectation that the individual thinks that the drug will help them have better memory or help them have better function that actually is what we're seeing. So what I'll do now is transition a little bit to talking about safety issues. So, okay, what we've seen is that there's mixed effects with regard to effectiveness. That it might improve in some individuals, but in the majority of people, having these medicines does not necessarily improve cognitive function. It might actually make it worse. So in thinking about that, then is it worth it, depending on what the safety issues are. So many individuals think because this is something that's given to children that, okay, children get this, why can't I take this? But there are risks involved, and methylphenidate, for example, which is what's shown here, has what we call a black box warning. So this is a serious warning from the Food and Drug Administration about the dangers of this medication. So it can be habit-forming, and the key is that if you take it not as prescribed, so if you're taking it without a prescription, what dose are you going to take? And the question is that if you take too much, you might see that the person starts thinking into what we call addictive behavior. And the reason for that is that part of what these drugs do is to improve cognition is activating this mesocortical pathway. But they also activate this mesolimbic pathway, this pathway of natural reward. And that's where it becomes dangerous, and that's where it can lead to addiction. And so it can basically do the same thing that certain drugs of abuse that we know of do, right? So the drugs of abuse, like alcohol, like cocaine, like many different, like heroin, for example, all of those drugs have one thing in common. And the thing that they have in common is that they increase the activity of this mesolimbic pathway. And so basically by increasing dopamine release in the mesolimbic pathway, you can induce a state of addiction. And so the off-label use of Adderall and Ritalin, again, what I mean by off-label is not using it as prescribed, right? So it wasn't prescribed to you. Off-label use of Adderall and Ritalin can have the same effect and lead to abuse and dependence like other drugs. So that's a very, very, very risky situation for having non-prescription use of these medicines. The other thing is that, you know, these medicines have side effects like every other thing. So some people, when they're prescribed a medicine, they weigh the risks and benefits. You know, I'm going to get better, but I know that I'm going to have these side effects. And so the question is, as a healthy individual, you're not treating a disorder, but yet you're subjecting yourself to some of the side effects. So for here's the example for Ritalin. Some of the side effects are listed here. These are moderate, right? So loss of appetite, nausea, vomiting, stomach pain, motor disturbances, and restlessness. But there are also very serious ones, and a lot of them have to do with cardiovascular issues. So these drugs are stimulants, so they increase your heart rate, increase your blood pressure. And there have been reports of individuals being taken having been treated in emergency because of taking these medicines without being prescribed and then having serious cardiovascular complications. The other thing is some of these drugs at very high doses can induce very, very similar symptoms to schizophrenia, which is a mental disorder. So hallucinations, for example, can be induced at high levels. And these are risks that are there for somebody who has been diagnosed with ADHD and has to take these, but they're treating a disorder, so they weigh the risks and benefits. The question is, for a healthy individual that you're not treating a disorder, are you willing to sacrifice, you know, cardiovascular complications or even psychotic symptoms for trying to improve cognition? This is from a study in 2010 where they basically surveyed ADHD patients for what were the more common symptoms. And again, the primary common symptoms are the moderate ones, right? So loss of appetite, sleep problems. Obviously, this is a stimulant, so it's going to keep you awake. Mood disturbances, and then some minor issues with nausea and headaches. Okay, so I think this is where I want to spend most of my time, and that is talking about some of the ethical considerations. So maybe I'll pause here and see if anybody has any other questions that we can answer in the meantime based on some of the effects that we just talked about in terms of who's using these enhancers and whether or not they're actually effective for the purposes of cognitive enhancing. So we'll pause and see if anybody has questions, and then we'll get into the ethical considerations, which I think might elicit a lot of discussion.
Okay. Again, just as a reminder, if you have a question or comment, go ahead and raise your hand using the hand icon, or feel free to type in your question or comment as well. So it looks like Scott Driscoll has a question that he's typed in. It says, do other stimulants like caffeine affect dopamine production similar to amphetamines? And the second part of that question is, will a cup of coffee, for example, help a child with ADHD focus?
Okay, good question, Scott. So the answer to that is no. So caffeine has effects on completely different neurotransmitters. So caffeine works primarily through blocking adenosine receptors. So it's not dopamine related. And so the effects to help kids with ADHD are related to the ability of amphetamines to increase dopamine in the prefrontal cortex specifically. So caffeine won't have that same effect.
Okay, Olivia Herlock has a question. What about lasting effects as an issue of using these drugs? Are there any studies about that?
So there are some, so I should say that they're not enough. We need to know what the long-term effects of some of these drugs are. But there have been some long-term studies done with ADHD children, and one of the more common things that comes out with methylphenidate, I believe, is that there is less growth in individuals that have been consistently treated with methylphenidate compared to others that sort of have been inconsistently on and off the drug, or others that have absolutely not ever taken the drug. So the only key long-term studies that I've seen are those effects on growth. But we definitely need more studies to look at what the overall long-term implications are of some of these medications. Absolutely.
And Olivia touched on sort of another part of that question, which was including consideration of these drugs as pathway drugs towards the use of other drugs.
The pathway question is an interesting question, and I have issues with calling anything a gateway drug, because you can pretty much call perhaps alcohol a gateway drug to nicotine, because some people who drink basically only smoke when they're drinking, for example. So I think I won't answer that question, because I have an issue with what we call a gateway drug. I guess you can call everything a gateway drug to something else, I suppose. That would be my answer to that.
Let's see, it looks like Mackenzie says, have you seen research or data on the use of natural substances like botanicals known as adaptogens in comparison to pharmaceuticals in the treatment of attention disorders?
I actually don't know some of that research, so I can't really answer that. My only concern with using botanicals is that whatever the active ingredients they are, sometimes we don't know what they are. And sometimes they can actually interfere with other medications that somebody might be on. So that's, if somebody's going to take botanicals, they should discuss with their doctor what they're taking, because you really need to make sure that the drugs, the active ingredients of some of the botanicals don't interfere with some other medications or might cause other complications.
Great. It looks like Katie Green has raised her hand. So Katie, I'm going to go ahead and unmute you, and you can ask your question or make your comment. Go ahead.
Great.
Hi, Katie.
Am I here? Hello?
Yeah, go ahead.
Oh, okay.
Hi, go ahead.
Hi. When you put up the graph showing people that were, below median and then above median, I'm wondering, is it possible that, were all the participants that were above median, were they all given the same dose of this neurocognitive enhancement, and how much of that their lower performance with the neurocognitive enhancement drug could be attributed possibly to the fact that the dosage they took popped them over that sweet spot, and if there was any possibility that if they were maybe given a smaller dose, they could have been more effective in the study.
Okay, Katie, that's a good question. Yeah, so they basically gave everybody the same dose, and typically the doses are either 10 milligrams or 20 milligrams, which is a typical pill. So they won't give anybody more than that just because of ethical reasons. But you're absolutely right. What if these guys were for them, the ones that ended up performing worse, that higher dose sort of took them over the edge. So that's definitely something that some of these researchers are looking into and doing dose responses. But again, the hard thing with that is that you're giving these medicines to healthy subjects. And so there's ethical issues with giving them multiple doses. But that's a great question, absolutely. That's definitely a possibility.
Great. And then we have, it looks like just one more question here. It says, based on the studies, couldn't it be argued that cosmetic pharmacology, aside from the placebo effect, actually be valid treatment for treating underperformers, even though the use of these medicines is off-label? And this is from David Slay.
Yeah, sure. So you could definitely make that argument. The question is, how do you know who's the underperformer? So you would have to have some sort of diagnostic test to say, okay, underperformers, you would qualify and this would actually help you. So then you would be able to use it. But that would be the key, is being able to diagnose and finding out ahead of time who the underperformers are to be able to treat them.
Okay, great. I think so.
Okay, and I think that's a good transition into talking about the ethical considerations, because again, we can kind of come back to that question and discuss, whether or not we should allow the use of these medicines without a prescription. So in terms of ethical considerations, I guess I'll divide my sections into talking about fairness, talking about coercion, and then talking about effects on society in general. So in the issue, when it comes to the issue of fairness, one of the things that a lot of people bring up is that would we be expanding social inequalities by allowing this? So in other words, drugs that are available for cognitive enhancement purposes would probably cost a lot of money, and they would only be available for people with financial means to get them, right? They're not a medicine that you would be able to get on your insurance, so you would have to pay for it outside of that. And so would that disproportionately influence or help, I guess, people that have more financial means, and in that way sort of increase the disparity in society between the haves and the have-nots? So that's an ethical question that we have to think about in terms of allowing the use of these drugs for cognitive enhancement. And we can, we can discuss it more a little bit later on the discussion in terms of what you guys think about that. The other issue is of coercion, meaning being forced to take the drug. And so this could be direct coercion or indirect. And so what we mean by direct coercion means that in order to keep your job, you have to take this. So in what situation might that be the case? For example, in the military, you might have to take these amphetamines to be able to stay awake, to do your mission. If you have a mission that requires you to stay awake multiple evenings, right? So then you're forced to take them as part of your job. Is that ethical? Is that okay to give somebody a drug like this that has powerful effects, and it's not for treating a disorder, in order for them to do their job? So that's the issue of direct coercion. So again, the question is, what if keeping one's job or remaining in one's school is dependent on practicing this cognitive enhancement? The other coercion is what we call indirect coercion. And that's, you can kind of amount it to peer pressure, right? So you say, okay, everybody in my class is taking these to do better. If I want to keep up, then I have to take it, right? So you don't necessarily want to take it, but you feel that you're forced to take it in order to keep up with everybody else. So that's what we mean by indirect coercion. And again, it always brings up the next question that, again, what if being able to do well in school depends upon me having to practice cognitive enhancement? And so again, I don't have answers to these questions, but these are all things that we have to think about when we think about being able to allow these drugs to be used for these purposes. And the last sort of ethical big umbrella is it beneficial to society? So sometimes you might ask somebody and say, it's my duty to do the best that I can so that I can benefit society, right? So if the best that I can means I should take some of these drugs so I'm performing at my most optimal level, and that in that way I'm benefiting society. What's wrong with that? So again, the other question too is, if everyone is smarter, won't we all as a society benefit? And so the idea would be, so let's say this is a normal curve of everybody's intellectual functioning, that then if somebody takes cognitive enhancers, that you would increase, basically shift that curve over to higher levels of intellectual ability, but then everybody would also be at those high levels. So wouldn't that be better for society if everybody was smarter? Wouldn't we make a lot better advancement in that way? The counter argument to that is, if you think about everybody having different intellectual capabilities and different sort of personalities, that as a society, we sometimes get really great benefits from everybody who thinks differently, who thinks outside the box, who's not in the middle of this bell curve, that might be at the end of this bell curve, at either end of these bell curves. So don't we as a society get great benefits from these individuals? And if everybody then is forced into the same box with cognitive enhancers, is that going to be actually beneficial? It might be detrimental to society to have that. So, you know, again, I don't have answers to these questions, but these are issues that are coming up. And it's not just something that I come up with in class, but it's basically scientists are beginning to ponder these issues. And so there's a lot of articles that are coming out, a lot of people talking about neurocognitive enhancement and whether or not, you know, what can we do and what should we do about it in terms of conversations about should there be laws, should we just allow people to use these for cognitive enhancing purposes, or we should regulate these things. So these are definitely things that are being talked about in high scientific circles, to the point where, again, in some cases, and in that paper, this is a quote that I pulled out from there, is some people are of the thought that it's not whether or not we need policies to govern neurocognitive enhancement, but it's what kind of policies. In other words, we're beyond the point of whether or not we need these policies. Obviously, people are using neurocognitive enhancement. We need to decide what kind of policies we need. And so recently, in 2006, a neuroethics society was actually founded, again, to ponder a lot of these very important questions, not just about neurocognitive enhancers, because, you know, the issue of brain imaging has also come up, but neurocognitive enhancers is playing a big role in the conversations that these guys are having. And so, again, to the point where there's conferences where these things are being discussed, or this is an example of a conference that took place in 2012, purely discussing cognitive enhancement in healthy people. And again, the scientists that you see listed on there are big people in their field, and they're having these conversations, trying to figure out what guidance we can provide for society in terms of sorting out the issues related to the use of these medicines. This one author, and I had this in the advanced readings, and if you haven't had a chance, I recommend you read this guy's paper, because he talks about really what should we do about this in terms of people using cognitive enhancers, and he also looks at how realistic is it for us to approve the use of amphetamines and methylphenidate by healthy adults. And he actually did a case study of each of these drugs, and one of the things that he concluded that for certain cases, for example, for the slow-release methylphenidate, where, you know, the person takes it orally, that it has very low abuse potential and it gets released slowly, that might be one that might be easily approved because, again, it doesn't have those risks that, for example, the quick-release tablets would in terms of addiction, right? So the methylphenidate slow-release might be something, if we were to approve, that might be the one that would be approved for use by healthy individuals, but not amphetamines because of the high risk of addiction when it comes to amphetamines, especially if somebody uses it at a dose that was not recommended and a route of administration that's not oral administration. But beyond doing that case study, what he also did, he said, okay, so he can envision that there's, excuse me, 4 potential models that we can think about if we were to allow the use of cognitive enhancers by the healthy. So one would be like the tobacco model, which is how cigarettes are today, right? So you can go and buy cigarettes from a store. They're highly taxed, but anybody can go get it. So that's a really lenient model. The coffee shop model, I guess you can think of it as like the marijuana model that's currently now used in Colorado, which is, you know, there's certain places where you can buy small amounts of marijuana legally, and you can possess a certain amount legally on your person, right? But it's a small amount. So that's what he's saying here. It's the same thing with some cognitive enhancers that you can, there's specific shops where you can get these, and you can get small amounts at a time. The third model, he says, is what the British Medical Association proposed, which is to establish a regulatory agency that's going to approve the use. So they're going to analyze each cognitive enhancer, and they're going to decide which ones can be approved, and then they're going to provide the guidance for responsible use of these medicines. And then the final one is this economic disincentives model, where the person who wants to use it has to get a license to use it. So how do they get a license? They have to take a course where they learn the risks of using these medicines, and they actually have to pay a really big fee to take this course. So that would be the disincentive, is that you have to pay a lot of money to get a license, but that part of this license involves you getting yourself educated as to what the risks are. Because I think in general, what Dublovic understands, and I think that we all see, is that people don't see the risks that are involved. But they see, because this is a medicine that can be used with children, then it's okay for me to use it, not thinking about what the risks of something like this are. So that perhaps a model like this, where somebody has to actually take a course, learn about the risks and the benefits, and actually pay a high fee to do this, that might be a disincentive for most people to use it. But then if somebody does have, for example, they know that they're an underperformer and they really want to do better, that's a route that they can use these drugs legally. So those are some things to think about. And we can talk a little bit more during the next question and answer period in terms of what you think about these different models and these different ethical issues. So just to summarize before we get to the next round of questions, again, what I talked about today was that Ritalin and Adderall and similar amphetamines, they work by increasing the levels of dopamine and norepinephrine in particular parts of the brain. In terms of effectiveness, we've seen that they may enhance cognition in lower performing individuals, but may be of no benefit or harm higher performing individuals. And in terms of safety, taking higher doses than recommended has a high risk of addiction and cardiovascular complications and other serious disturbances like psychotic episodes. And somebody asked the question about the long-term effects. We really don't know much about the long-term effects of these drugs, so that's definitely something to consider. And again, there are a lot of these ethical questions that I wrote about at the end. It's not just scientists that need to address it. It has to be scientists, it has to be physicians, it has to be lawyers, it has to be policymakers, it has to be everybody working together to try to figure out what's the best way to handle something that's becoming so much more prevalent in our society. So I hope that you learned a lot from today's talk. And again, right now what I think is I raised a lot of interesting ethical points at the end, and I'm wondering if anybody has any questions or comments about any of those issues. So I think now is the time for you to provide your questions or comments or your thoughts on any of these issues.
Okay, we'll take a look again here to see if anybody has their hand raised or any final questions that you'd like to go ahead and type in. So I'm just taking a look through the roster. Okay, we have a hand raised from Mark Stevens. Mark, go ahead and make your comment or ask your question. Mark, go ahead.
Mine is more of a hypothetical question, Doctor. If a student is flunking your course and he comes to you during office hours, are you going to open up your desk drawer and say, well, I have this sample kit from Pharmco for cognitive medication. I suggest you take it if you want to get through the course?
That's an easy one for me to say. No, I'm not. I wouldn't be somebody who would advocate that. Again, I think that there's a lot of serious risks and safety issues to consider before we can get to the point where you can just easily say, here, take this and you'll do better. The other thing is that, and you actually bring up a good point, is that it's not just taking the drug, right? So that you also have to take the drug and do the work if you want to do better. It's not that taking the drug is just going to miraculously help you know things that you didn't know before, that you still have to sit there and actually get through the material so that you can learn it. So there's still work involved.
All right, great. Thanks, Mark. Let's see if we've got any other hands raised first, and then we'll see if there are any other typed questions. Okay, let's see. Okay, it looks like we do have a A question from Susan North. It says, it seems that if the results were more positive across the board, the ethical issues may be more thought-provoking. As it stands, the effectiveness of the drug is not consistent. So the idea that someone would take it because they had to, either directly or not, is less compelling.
Yep, you're absolutely right. So at this point, but the question is, not everybody realizes that the efficacy of the drug has not been proven. So at this point, people are like, okay, well, you know, if everybody else is doing it, I'm going to have to keep up, not realizing that, you know what, the efficacy of these drugs have not necessarily been shown rigorously and unequivocally. So you're absolutely right. It's not compelling because you know that they're not necessarily very effective, but the general population does not necessarily know that. So that's a good point.
Okay, we've got another typed question. It says, I think that with the model that deals with regulation, with the expensive class, would probably lead to more people using it illegally because of the high amount of money that it would require.
So if I guess your question is, if we went to that model as society where people would have to pay for a class to get it legally, that you're saying, you know, people are not going to want to pay for that class, so they'd just rather get it off the streets. I guess that's the point, but you know, I guess that's what they're doing now. So I don't know. It might improve if we have another option for people to obtain it legally, because at this point, most people who are using it without a prescription are getting it illegally from people that they know, and people. Or primarily I'm thinking of the example of students who might have ADHD and sell some of their pills to their friends, or people obtain them by other illegal means. So maybe that will still continue, but maybe there will be people that will see this as a legitimate way to avoid having to do that and actually take the class and actually learn about the cost benefits, I guess, of using these drugs. But that's a good point.
All right. Any final comments or questions before we end the night? Just taking one last look through our attendees.
Is Liam still on there? Oh, yeah. So I have quite a few former students that are out there. I just wanted to thank you for joining me tonight, and I wanted to wish Liam a happy birthday. Today's his birthday. So happy birthday, Liam, and I'm happy that you spent it here with me learning about cognitive enhancers.
Great. So we've just got quite a few comments coming in saying thank you very much for doing this, Dr. Estevez. It was very, very informational. So again, you can see Anna's contact information on the screen now, including her email and phone. So if you didn't have a chance to ask a question or to make a comment tonight and you'd like to do that, go ahead and reach out to Anna directly. Is there anything else that you wanted to say in conclusion? Oh, I think we might have just had one other comment that came in. So we'll go back to that for just a second. It says, how do healthy individuals that use these drugs know if they fall in the below-performing spectrum versus the high-performing spectrum? In other words, how do they know they are hurting their performance?
It's hard to know. That's one of the tough questions, that we don't know ahead of time where somebody is on the spectrum and how the drug might affect them. So it's basically on an individual basis. Everybody's different. So that's one of the risks, right? So what if you're already a high performer and then you take the medicine and actually makes things worse? That's definitely an issue to consider. But yeah, we don't know ahead of time. And that's one of the risks. If you're a low performer, it might help you, but if you're a high performer, then you know it's a risk. It's a big risk.
All right, great. It looks like those are all of the questions for tonight. I want to conclude tonight's lecture. Thank everyone for participating and thanking Dr. Estevez for sharing her expertise on this topic with all of us. Right after the webinar concludes, you will receive a brief survey. I'd ask you to just take a moment to fill out those few questions, as it will definitely help shape future lectures in this online Laurentian lecture series. So thank you to everyone for participating and for your thoughtful comments and questions, and have a wonderful evening.
Thank you. Good night.